Okay, so here you see the brazing and shouldering. This process is called solid liquid both. It is not just solid, it is not just liquid, but it combines both solid liquid joining process. Why? Because in this process the component to be joined, these remain in solid state, they are not brought to the molten state. But a low melting point metal like this, low melting point metal, you can say as a filler metal, that is placed, and then through the application of heat from the suitable source, this molten metal, this filler metal melts. So the filler metal obviously will be having the lower melting point than the base metal. The base metal, which is solid, has the higher melting point, much higher melting point than the filler metal. So only filler metal is brought to the molten state. So depending upon the melting point of the filler metal, say the base metal may have melting point around 1000 or 1200 degrees centigrade or 1500 degrees centigrade. But the filler metals we use, say hardly around, say there are two categories of the filler metals. One which like say melts less than 450 degrees centigrade, and another which melts above 450 degrees centigrade, but in this case less than the base metal. Okay, so in both the cases the filler metal will be having the temperature lower than the base metal. So it is a very simple thing. The components to be joined, you put the components in a proper spacing. Okay, so spacers certainly can be used, and then in this space, this you can call as a clearance space. This is very crucial. This clearance space is important. So what we do, we put the filler metal here, okay, and then apply suitable heat source. So this melts, and then through the capillary action it gets spread in between the surfaces to be joined. So the component to be joined, these remain in solid state, but only the filler metal is brought to the molten state. That's why it is called solid liquid joining. Okay, since you don't need the melting of the base metal, so the heat applied is very less. You are using the filler metal of the lower melting point, therefore the heat applied, less heat input is used. Since it is the heat which is being supplied to the base metal is a problem creator because of the localized melting, localized heating, so that is leading to the lot of issues in fusion welding, like what we have seen in case of the gas welding and in arc welding. So those issues, those problems are minimized, or many are eliminated, because the heat input is extremely less in this case. Okay, so again there are two categories of the processes when the filler metal being used. So basically the principle in both brazing and soldering is same. Both the base metals remain in solid state. Only the heat is supplied to melt the filler metal. Filler metals are of the two categories. One where the melting point of the filler metal is less than 450. In this case, we call the process as a soldering. Okay, when the filler metal has the melting point greater than the 450, we call it as a brazing. Okay, so this is the major difference. In both the cases, the metal between the components to be joined, like say this is the geometry and this is another component. So what we'll be doing, we'll be putting the filler metal here, and then this component will be inserted here and apply heat. So the filler metal will be brought to the molten state, and after the solidification will be getting a joint. Okay, so the good part here is that there is no melting of base metal. Okay, very less heat is supplied. So these are the two very crucial things. Because of this, we have very less heat affected zone. There is no compromise. Literally, there is no compromise with the base metal properties. So that is another good part. So there is no residual stresses and distortion tendency, what you have seen in case of the arc welding, and there is no typical defects like pores, like what we have seen in case of the inclusions, etc. Especially in the base. So base metal remains largely unaffected. Some of the impurities may be there in the shouldered zone. So how the joint is formed, you see, this is the one component, this is the another component, okay, and between these two you have filled in the filler metal, low melting point filler metal. As per the process, it may be called as per the filler, it may be called as a brazing or soldering. So this shoulder, how the joint is being formed, that is what you see. The the filler metal like brazing material or the soldering material, these are the low melting point materials. So these are weak, of the low strength. These melt at very low temperature, while the base metal is of the high melting point. So these are strong. So this is the weak link. So but what is contributing towards the joint formation? So the shoulder, you see, the solder or the brazing material, this is supposed to react chemically with the base metal. So when it reacts or interacts, what it forms? It forms some kind of the intermetallic between the base metal and the brazing or soldering material. So one IMC layer is being intermetallic compound layer is formed between the, say, base metal 1 and the brazing or soldering material. Similarly, the another IMC layer is being formed between the soldering or brazing material and the base material 2. Okay, so this is extremely important for the joint formation, and this is the result of the diffusion of the elements from brazing and soldering material to the base materials, both the sides. So the diffusion is responsible. So whatever the low temperature is there, that is leading to the formation of the IMCs. Now here you see how the joint fails. The base metals are strong, both base metals are strong actually, right, and here you have brazing or soldering material. So since the brazing and soldering is extremely weak, so it is possible that the failure of the brazing material itself or soldering material itself takes place while the interfaces remains strong. So this is one possibility where the brazing material fails. But if the interface between the brazing material or brazed joint layer and the base metal, it is poor. So if this bonding is poor, this side bonding or IMC being formed is poor, then your separation may take place from this base metal and the brazed interface. Failure can occur from either from the brazed or the solder material itself, here, that is say A and A, or it can occur from the B and B, that is the interface between the base and solder material, B and B. So these are the two possibilities. The third one, when the joint is still stronger than the base metal. So if this is weak, then failure may occur from here. So these are three possibilities: either the brazed or the soldered layer will fail, or the base or the soldered layer and the base metal, brazed material, soldered material and the base metal interface failure will take place, or the weak base metal can fail. So these are the three situations by which these kind of the joints can fail. Now, what is the need to have this kind of the joining approach? Because still, despite of the situation where the joint is weak, so because here you see the joint is not as strong that the base metal, but still we are using when this can be. So we even weak joints, many times we don't need the very strong joints. You need just the two components are placed with respect to each other in correct position. So if that is the case, then what you will be having, you can have the brazed joint or soldered joint. You want this just for electrical conductivity, just electrical connection is needed, there is no mechanical loading, or just heat is to be transferred, there is no mechanical loading. So just for the situations where heat is to be transferred between the two members and those need to be connected together, or electrical current is flowing, or some other kind of the, not just stresses, but some say fluid flow is taking place, so the two need to be connected just to make sure that they are leak proof, so there is no flow of fluid from these two from the junction of these two members. Okay, so it is, that is why it is commonly used in the heat exchangers, which are used like to transfer the heat. It's a device which is used to transfer the heat from one side to another, which may be like solid, also which may be gas or the liquid. Okay, then another is in electrical and electronics field. Electrical and electronics fields, wherever significant connections need to be made, so your brazing and soldering related things are extensive. Even in automobiles, like a radiator where heat exchanger for cooling the engine, a radiator is used, so there also the brazing and soldering is used. In refrigerators, this is extensively used. So these are some of the typical applications where no stresses, just the current or the heat flow or the fluid flow is to be facilitated. Okay, so what are the situations, so where this kind of the joining is needed? Say when the two components, say A and B, need to be joined, A and B need to be joined, these cannot be fused together to develop the joint, because the joint, whenever they are fused, the joint is extremely weak. So the fusion of the A and B is and thereafter development of the joint between the two is not workable due to the metallurgical incompatibility. So the thing is, like say steel and aluminum, when these two are fused, it forms something which is extremely weak, and we are very poor in terms of the joining joint properties. The second one is that like the two can be joined, or like say A metal, A is to be joined with A, but whenever we apply heat, okay, whenever we apply heat, it creates a lot of problems in the heat affected zone and in the welding zone. So the metal is very poor or very difficult to weld, very poor in welding, or you can say difficult to weld. Still the joint difficult to weld, still the joint connection is needed. If the joint is needed, we can use brazing and soldering. Okay, so we can say this as a very low weldability metal is the another situation where this kind of the connection may be needed. Third situation, where you want to minimize the heat affected zone. So since the very less heat input is there in this kind of the process, so that has to be and if the HZ is to be minimized, low heat input coupled with the brazing and soldering will be leading to the very reduced heat input. Okay, third is you see the joints are need very low, need to work under the low stress conditions or very low temperature conditions, then this is okay. You see, so for non-critical, so it's very cost effective in that way. Okay, so these are some of the situations where the brazing and soldering joints may be useful. Now I'll be showing typical details related with this. Hopefully that will help to understand the things. So this is what the basic the part related with this. I have left with just one thing, so that is about this capillary action. So let me talk about that as well. So here if you see yeah, you know, like say these are the components to be joined. So as I said, the spacing between the two components to be joined is called clearance, and this has to be very closely maintained, say 0.15 mm to 0.01 mm. Okay, or you can say 0.15 to yeah, it's like this. So the very close gap has to be maintained. So this is the brazing or filler material. When it is heated, it melts. Okay, so when it will melt, it will be leading to the formation of oxides. Okay, it will be leading to the reactions with the gases which are all around. So these also need to be taken care of. At the same time, this molten metal of the filler metal of brazing or soldering material, this should be fluid enough, it should be thin enough, so that it, by capillary action, it gets spread all along the gap, in the gap between the so this spreading by capillary action is extremely determined by the two factors. One is clearance and another is cleanliness. So the surfaces must be clean enough so that the molten brazing or filler metal can get sucked into or can get spread between the fin surfaces at the interface very effectively, and it should be clearance should be properly controlled, and another one, it should be smooth as well. If it is rough, then also the capillary action is reduced. So you are not doing anything for the spreading of the molten metal, it is just spreading at the interface through the capillary action between the fin surfaces. So that has to have that uniform spreading, like say, to have the uniform spreading, these are the two members, you are putting the filler metal here, so it should get spread all along the interface. So if this spreading is not proper, then certainly some of the non-contacted unjoined region will be left, and that will be leading to the defects. Okay, so clearance, cleanliness and smoothness, these are the three important things. And to remove the oxides present on the surfaces, to reduce the impurities present in the interface, and to remove the oxides, some kind of the fluxes are always added in the brazing and soldering process. So these fluxes basically help in number of ways. These improve the fluidity of the molten metal, improve the cleaning by removing the impurities. Okay, and these help in forming the slag by reacting with these oxides, etc. So the fluxes are invariably, so what we do, first we apply the flux at the surfaces to be joined. Okay, then we put the filler metal like a brazing or soldering material, then apply heat. So heat application will be melting the flux as well as the filler metal and the flux, these two interact with each other, which help in removing the impurities, cleaning, improving the fluidity as well as removing the slag. So this is the role of the fluxes as well. Now I'll show you one PPT quickly. Okay, this is the brazing and soldering. I have already talked the two metals to be joined here. Okay, two metals to be joined, and the flame is applied through the with the help of the torch, or there can be number of the sources of the heat, and this is the filler metal. So the brazing can also be there in braze welding, where there is no capillary action, just the two components edges are prepared like this, and between them you put the filler metal. So it is like similar to the welding, but there is no fusion of the base metal. Okay, these are like the brazing material can be in form of wires, strips, rings, shims, preforms, and powders. Preform is like a thin sheet which is in form of the shape which is desired. Then the filler metal is chosen in such a way that it is compatible to both the base metals A, B and A. So C type of the filler metal will be chosen in such a way that it works better with both the filler metal. So in that way it helps in reducing the Embrittlement of the joint avoids the formation of the brittle IMC. Rather, it forms the good IMC, that is always desirable, and it also helps in reducing the galvanic corrosion. These are the common kind of the brazing materials. Okay, aluminum alloys. All these you will see having the temperature greater than the 450. These are the common. The brazing material as per the strength of the joint which is needed, as per the base metal to be joined, the different types of the brazing materials. These are the different types of the brazing materials which can be used. As per the kind of the source of the heat being used, for melting the fluxes, melting the brazing material, and heating the base metals to the sufficient temperature so that the brazing or soldering can be facilitated. The brazing where the torch flame is used, gas torch flame is used for the purpose of the heating. In the furnace brazing, like the suitable furnace, the components in with the you see these are two components to be joined, and the filler metal is pre-placed, and this entire component is placed in the furnace, so that on the solidification, on the melting the filler metal, on heating the filler metal melts, and then subsequently on solidification we get the suitable joint. Similarly, there can be induction brazing where induction heat is used for melting the filler metal. There can be dip brazing where the molten bath of the molten metal, the molten filler metal is used. So in the dip brazing we use the brazed molten filler or molten bath is used, in which the assembly is dipped and then taken out. After the solidification we get the joint. In the resistance welding or in the resistance brazing, electrical resistance heating is used basically to facilitate the brazing, and similarly in the induction brazing, induction heat is used. So this is a simple difference. These are the different configurations in which the different types of the joints which are used for the brazing purpose. So here the joint is made at this junction, joint is made here, then the joint is made in this zone. So depending upon the kind of the connection to be made, the different kind of the configurations. So for joining the pipes, here the joint will be made, joint can be made like this. So there are different kind of the joint designs which can be used for developing the brazed joints. Okay. Then as far as the soldering is concerned, soldering and brazing both are same, except the difference is in terms of the melting point of the filler metal which is being used, and since it needs very less heat, so soldering iron, torches, or even ovens can be used for this purpose. Common solders are like lead tin, but the problem with the lead is it is very toxic, so nowadays lead free solders are also being developed. Okay, so here you see the tin and zinc, lead silver, cadmium silver, zinc aluminium. These are some of the kind of the solders which are used. And then tin based solders are typical. These are the few tin based solders. So nowadays efforts are being made to develop the solders without lead. Okay, so the common solders and their applications, you see. And the fluxes for soldering, then organic acids, salts, etc., like the ammonium, zinc ammonium chloride solutions for in the organic category, of the soldering fluxes. So these fluxes are basically corrosive, so these must be cleaned actually whenever these are used. So the lead, tin, then tin zinc, and the tin silver, tin bismuth, lead silver, cadmium. These are the typical solders and their applications. And this is like the depending upon the source of the heat being used, there are different methods of the soldering process. Most commonly for developing the electrical connections, the soldering is usually performed through the soldering iron kind of thing.